limits at infinity. Okay, when we talk about limits at infinity, we basically have three cases. The first case, we can say the first case is when the degree of the numerator is greater than the degree of the denominator, right? The second case would be when the degree of the denominator, or when the degree of the numerator is less than the degree of the denominator, right? And the third case will be when the degree of the numerator is equal to the degree of the denominator. What means degree? Means the power of the greatest x that I have. It could be on the numerator or the denominator. Okay, that means degree. So what happens when I have the first case? When I have the first case, when the degree of the numerator is greater than the degree of the denominator, my answer would be infinity. And when the degree of the numerator is less than the degree of the denominator, my answer would be 0. And when the degree of the numerator is equal to the degree of the denominator, my answer would be related to the leading coefficients, right? So basically, these properties are the ones that I'm going to use for this kind of limits. Okay, so let's identify which case is this one that we have. The limit as x approaches infinity of -3 divided by x. So we can see that on the denominator I have x to the power of 1, right? And since on the numerator I have only a constant, that means that the degree here, since I don't have an x, the x is to the power of 0, right? So I can see here that the degree of my denominator is greater than the degree of my numerator, right? I can say that I'm talking about which case, the first, the second, or the third. Let's see. I think this is the second case, because the degree of my numerator is 0 and the degree of my denominator is 1. So I can say that 1 is greater than 0. So that means that I'm relating this. Okay, so if I know that, I can say that this limit is equal to 0. Only looking at these three properties of limits at infinity. And why this happens, I can justify this answer by doing the plugging in, right? Because if I divide -3 divided by infinity, or a really big number, what I'm going to get, since I'm dividing a very small number divided by a really big number, I will get a negative, but really, really close to 0. So since the 0 is has no sign, so then the number that I'm approaching is 0 here, right? And that's how you justify this first case. So let's go to the second case of limits at infinity. Okay, so let me write down always the cases. So the first one is when the degree of the numerator is greater than the degree of the denominator. In this case, we know that this is infinity. The second case says when the degree of the denominator, or when the degree of the numerator is less than the degree of the denominator. In this case is 0. And the third case is when the degrees are equal, right? When the degree of the numerator and the denominator are equal, right? So in this case, I work with leading coefficients, right? So let's check. I have only x, and here I have x to the power of 2. So which one is greater? I can see that the power of the numerator is greater than the power of the denominator, of the x that I have on the denominator. So I'm dealing with 2 greater than 1, right? So that means that I can relate to this one. So if I use properties, this limit should be equal to infinity. And that's it. That's the answer. And it makes sense, right? Because remember that when we use infinite limits, we work only with the leading coefficients, right? Or the leading x's of each one, right? So I will have, if I plug in, I will get infinity squared divided by infinity. So I can cancel these two because I know that the negative 9 and the 7 are insignificant, right, or irrelevant. So I can say that this would be only infinity. That's how I can justify by using the properties. Okay, so let's go to the last case. Okay, so always write down the cases. The degree of the numerator is greater than the degree of the denominator. That means that the limit is infinity. The second case is when the degree of the numerator is less than the degree of the denominator. That means that the limit is 0. And the third one, when the degrees are equal, right, the limit should be related to leading coefficients, right? Okay, so we have here two polynomials, two quadratic polynomials. So that means that I have a quadratic here and I also have a quadratic here. So that means that the powers that I'm dealing with are the same. So the powers are equal of the greatest x, right? So I'm dealing with the third case. So what does leading coefficient means? Leading coefficient is the number that is next to the x with the greatest power, right? So in this case, I can say that the leading coefficients are the 4 and the 7. So basically, my answer should be equal to what? 4 divided by 7. And that's it. That's the limit. And how can I justify that? By plugging in, right? If I plug in 4 and 7, I will have infinity squared here and infinity squared here. So I can cancel these two, and basically I will end up with 4 divided by 7. That's how I can justify this by using properties. So these are the three properties that you should know for infinite limits.